Welcome back. Uh, Today's topic, obviously within the title, is about the debate going on right now amongst YouTube channels pertaining to piston design or modification. So, for the last week or so, Uncle Tony's Garage, Paul Machine, other YouTube channels that I'm not so familiar with have gone on to discuss the knurling for the smoking unit pistons. And it seems like these individuals have actually gotten on the phone with each other and talked over their discrepancies within the debate. So while we have the debate about multiple different products made for the performance industry or engine performance, we have to come to a conclusion that you can have your own opinions, but does that mean that it's necessarily right? This is where, going back kind of to the David Vizard videos, his introduction into it, saying that we're not here for the speculation, we're here for the proof. Now, there are some things within engine assembly, common practices or beliefs that have been adopted by the performance industry, that they're worth more power, so on and so forth, which are complete bogus. But it's just become the common practice, the psyche of the individuals in the industry saying that you have to use this type of equipment now because this is where the most performance comes in, or the gimmicks, the sales gimmicks of this is what you need to get the greatest amount of power. One of those engine components that I can, again, we can debate this, I guess if you want to call it that, within roller rockers. Okay, one of the most debated engine components is within roller rocker design, especially at the entry level, okay, of engine performance or assembly. If you're utilizing a stamped steel rocker with no roller tip and no roller trunnion, are you necessarily sacrificing any horsepower by utilizing those? Do you gain a bunch of horsepower by switching to a roller tipped stamped steel rocker? Do you gain a bunch of horsepower by going to a rollerized trunnion? All of the different dyno tests over decades have not necessarily proven that they're worth more horsepower. They're there to reduce friction. And the quantity of power that they might gain is not necessarily measurable at performance levels, say under 600-700 horsepower. It's more about the longevity and the reduced friction and extended life out of the components. It's not necessarily for the additional horsepower. So one of these other YouTube channels following my piston video commented on the smoky unit knurling process. They're the same individuals that have come out and actually spoken about crankshafts. If you have a groove that runs the radius of a crankshaft journal from either foreign material or metal material that got through the bearing and actually scored the crankshaft, you don't necessarily have to repolish that journal because the grooves are actually an indentation that will carry additional oil. Okay. That's the thinking behind it. Of obviously it's so minute, the amount of oil that fills that groove is not going to deter any kind of additional horsepower or cause any damage to the new bearing surfaces, because they're inside of the material. That area is just going to be filled with oil. Does that mean you're going to go through all of your crank journals and purposely grind grooves into them to carry more oil and to reduce more friction? So it was a very good conversation, or basically a comparison. The knurling aspect was to reduce surface area and also allow more oil to be between the skirt of the piston and the cylinder wall. Individuals like Lake Speed and the oil marketing gurus out there, yes, the oil geeks as they even call themselves, saying that the finish of the cylinder wall is to carry the oil as the piston rings are moving over that structure, that fine, minute, abrasive surface, that the oil actually fills in the gaps, and then that allows the piston rings to basically float across the top of them. When the purpose of the piston ring is to seal, okay, or to scrape the oil away from the cylinder wall. So all of these debates that are going on, we can come to the conclusion of you have your opinion, I have my opinion, but there's only one right answer. And that's the point of a debate, is to get to the final answer. Now, for anybody that knows me in my personal life, I'm involved with politics, not only with what's going on and, within the presidential elections and so on and so forth. I've actually run for politics in my local region. And I can tell you the things that happen behind the scenes, there's a lot of debate. And it's to please the individuals, basically sometimes the voters, in order to appease to the voters that will get you elected in office. You basically just use the excuse of, we're going to debate this and we can see things from different points of view, but that does not determine the actual fact, the actual truth. So don't allow politics into the mechanics or performance industry. Do not allow politics to bring you to this debate. Get down to the fact. Now, approximately a month ago, I believe this debate started from Brent from Lankins Motorsports. He assembled an engine with very tight tolerances between the cylinder wall and the piston itself. And he had some issues with it. I created a video basically saying, you need a certain amount of cylinder wall clearance between the piston, and even the piston manufacturers will recommend a small percentage multiplied by the actual diameter of the bore, and that should be your wall thickness. Now, we also have individuals coming out and saying that pistons are not perfectly round. Okay, that is true from not only the face of the piston or the head of the piston to the skirt. They are not perfectly round. When you are measuring them outside of the engine with a micrometer. But once you start exposing them to the heat, okay, of both the frictions of the side of the piston and the heat inside the cylinders themselves from the combustion process, pistons will swell in different orientations so that when they are up to operating temperature, the pistons are round. So again, going back to the debate, you can think and promote everything that you believe, that you are within common practice within the industry. But the fact is, when an engine is running, what are the parts doing? And that's the fact, that's the truth. So again, a running engine with knurled pistons, did it show advantages to additional horsepower? Smokey Yunick proved it already during the time of the beliefs and practices of that era. Pistons have advanced in technology. So as I was researching data to back up my debate, okay, I came upon a 2013 SEMA show with one of the piston manufacturers, one of the top two piston manufacturers that I like to use within performance builds. Wiseco and JE are my favorite. For heavy duty applications, I always turn to JE. For things that are more high RPM, circle track type racing, I switched to Wiseco. And Wiseco came out in the 2013 SEMA show with a windowed piston design. Wiseco has been always attempting to design a piston that's lighter weight, will maintain more control and centralization of the piston in the bores, and they attempted something for about a year. They did put it in research and development, and just within the last month, another publisher wrote about this piston. So any of you want to look that up, just look at the windowed piston from Wiseco, and you'll see the different pictures and the test on it. Look up the articles within your search engine. Read them. There was one, like I said, just here in 2025, asking whatever happened to the windowed pistons of from the SEMA show back then. Again, research and development. Why are pistons still being constructed to look in this fashion? Because it's the cheapest manufacturing process. Okay, it is not the highest performance. So even when individuals that initiated the whole smoking unit, knurling, even the individuals that own the same machines that Smokey used, they're already marketing for the pistons that they use in their builds, saying these are the best. Okay, choose your words wisely, because they are not the best. They are just the ones that you have used for your applications, period. They're not the best. Because if you look at the best pistons created in the world, you're not going to find them in your daily driver. You're going to find them in Formula One, okay? You're going to find them in NASCAR. Typically, those pistons are extremely expensive, for one, and for somebody building a street-driven, drag, lower drag racing type vehicle, they're not going to take advantage of those pistons. So you could have the best Formula One piston, put it in your 350 horsepower car, and it's not going to, wake it up and make it a 500 horsepower car just because of the piston design. Just like going back to the roller rockers, it's a debatable topic, and some dyno sessions have shown an additional amount of power. Okay, arguably less than, say, 10 horsepower difference by switching from a stamped steel to a roller. Realize that the design is not necessarily for additional horsepower, it's to reduce friction and create a longer lasting valve guide, because there's less sideward motion being put onto the top of the valve to cause it to rub on the valve guide one way or the other. Now, even with roller rocker technology, are the manufacturers installing roller rockers on every one of their engines? For instance, let's look at the LS variation. Are LS still utilizing a solid tip rocker? Yes, they've gone to a rollerized trunnion pivot point within a rocker, but the tips are still solid. Why? Okay, it's the cost of production and any kind of failure that might occur with the roller itself. Even switching from a flat tappet camshaft to a roller, there might be advantages to the roller, but now you're adding something else, another mechanical component in the engine that could fail. Especially with the needle bearings and how aggressive the ramp rates are and so on and so forth, or the amount of oil that goes onto it. Once again, you can go back approximately a month ago, maybe even 2 months ago, of where Callie's, I believe it was Callie's, invited Lake Speed to their manufacturing facility within their lab, and described all of the different roller rockers and how the oil that is being produced is being taken into account of how they're designing the lifter. But is it for additional horsepower? Where's the fact? Where's the debate in this? So while this debate is occurring within the industry, especially between two individuals in the Southeast, it's not the facts. I want to give you an extreme example. That's something that we're experiencing here in the United States, and it is a political thing. Okay, so I don't necessarily like to talk about politics on this channel. I do in my regular life on a daily basis. But I'm going to use this as an extreme example. It might upset some of you, and depending on where you live in the world, it might be something you've learned to live with or accept, but it doesn't change the fact. We have the delusion right now in the United States about transgender individuals that are born with a certain gender, and they believe that they, if they're born male, that they can transition into a female. Even individuals that might have, visited the Philippines, okay, You can walk through town and you might see an individual that looks like a nice curvy woman, but it doesn't change their DNA. If they were born male, they stay male. So we can have a debate of whether or not this is a mental illness within individuals believing they're one thing or another. But we have to get right down to the facts. The facts are your DNA, something that cannot be changed, that is designed and constructed by God. Humans cannot change it. They can change the appearance, but it doesn't change the facts. So utilizing that extreme example here in the United States, when we have a friendly debate about a certain topic, we can agree to disagree, but that does not change the facts. It is something worth arguing about. It is something worth demanding and getting mad about, because again, you can debate and say, okay, we're going to believe this differently and so on and so forth. But what are the facts? Additional oil between the cylinder wall and skirt reduces friction and allows heat to be shed from the piston as that oil then drains back. Does it necessarily produce an additional 30 horsepower to an engine? No, especially when you're working with engines that are only achieving approximately 60% efficiency. When you start getting into extreme performance engines, Formula One, turbo engines making over 3,000 horsepower, diesel applications with over 120 pounds of pressure from the turbo system on the pistons, that's when the small, minute changes within piston design start to become obvious. At that point, then you will see the performance advantages. For example, it has been a debate in the performance industry about dimpling the intake system, whether or not that creates a barrier of where the fuel and air can separate, to even dimpling the top of the pistons. You can take your ordinary piston, put all kinds of coatings on it, dimple the top, and run it with fuel, and you think you're going to gain a whole bunch of horsepower when you necessarily are not. But if you start looking at the highest performance diesel engine applications now, they are all utilizing dimpled pistons, especially those with increased performance. So diesel applications making more than 800 foot-pounds of torque and over 1,000 horsepower with 20 to 120 pounds of pressure being produced by the supercharger, then you will actually see a performance difference in the maneuvers or in the modifications. When we're talking about engines in that 300 to 900 horsepower range, these modifications are not going to be as evident. Now, going back to one of the most debated components within a running engine, if you have a 450 horsepower engine right now that you have built with factory stamped steel type rockers, and you switch to a roller tip, you put it on a dyno, are you necessarily going to see a huge power increase? Maybe 2, 3, if you can get an apples to apples comparison. If you go to a full rollerized rocker, are you going to see an additional horsepower increase? You're relieving the amount of restriction to create the power that the engine is capable of doing. You're not making more, you're removing things that keep it from actually producing more horsepower at the crank. You're also adding longevity to the components, because again, a regular stamped steel rocker with no roller trunnion or roller tip, it forces pressures left and right on the valve itself, moving and causing that valve stem to rub one way or the other upon the valve guide. But the valve should also be rotating so that it is shared as the valve is turning within the valve guide. It's not wearing out one specific area. That's why you don't have square valve stems. They need to rotate. Now, by throwing on a roller tip, it's to reduce that sidewards to sideward motion during the sweep of the rocker across the valve tip. Is it worth a bunch of horsepower and something in the 300 to 900 horsepower range? Probably not. When you start getting up to extreme RPMs, that reduced friction and valve train control can add additional RPM and reduce the amount of friction, robbing horsepower from the combination. You're not creating more horsepower, you're releasing the friction to allow the horsepower to actually make it through. Is it a measurable amount? The fact is, not that much until you get extreme numbers. So again, let's squash this debate, because some of the individuals involved with this debate, they should be talking. You know exactly who I'm talking about. They're the same individuals that come out on YouTube, called me out over different things, saying, that's not true, this is right. It's stuff that we already learned. Things that been there, done that, and already wrote an article about it and showed the proof over an extended period of time. Stop debating the small little things unless you have built those extreme power applications to show the proof. You're not going to notice it with your standard engine. Knurling the pistons, again, might have given Smokey Yunick an advantage at that point. Realize the oils and the consistency, the machine work of the pistons and cylinder wall construction at the time was totally different than what it is today. Going from a fixed connected wrist pin to a floating wrist pin, again, is it worth additional horsepower? No, it's not creating more horsepower. It is reducing the friction that robs the horsepower that the combination is capable of making. So instead of thinking in the addition, think about the subtraction. You're subtracting restriction to the engine for it to produce the power that it possibly can. You're reducing the obstacles of creating the horsepower. So with that, again, coming down, and a lot of people are already starting to get involved with this debate. Even videos that I was not aware of. When I created previous ones, I had not watched the videos from Daniel Powell or Powell Machine. I had not turned onto his channel since he called me out. All the information he was sharing, especially with camshafts, I immediately got away from it. I'm not going to take that kind of stuff. And now he's complaining in his latest video, yes, I did tune in, about all the extreme negative comments coming towards him. In previous videos, even going back to the first one in this list, it's called karma. In debates, when you start debating things, you can agree to disagree. But that is avoiding the facts. And that's what people turn to YouTube for. It's not only for the entertainment value, it's to get down to the facts. And a lot of information being shared by so-called professionals are a complete crock of crap. They're there to sell you something. Whether it's a product or their opinion, it's still not getting down to the actual fact. So, a little bit of a rant here. We can talk about all the different components in an engine or procedures to increase horsepower. We can't necessarily debate if there's a difference or not. If it creates more power, is it necessarily creating the horsepower, or is it reducing the friction for the platform to actually create the horsepower? A lot of technology inside of a V8 engine today is to reduce the stresses on the components, to reduce friction, to allow the combination to run more efficiently, and that's where the power comes from. Unless you're adding something like nitrous oxide or forced induction, that's actually the positive. You're actually adding power to the combination. Roller tipped rockers, knurling pistons, roller cams, those are all things that are reducing friction or allowing the actions and mechanics of the engine to act differently. They're not necessarily producing more power. So we got to get down to the facts. You can debate this all you want. I'm not going to have any continued videos covering any of these topics from these certain channels because, once again, I disagree with what a lot they say, and I disagree because of my experience. I know what works, doesn't work, and what most individuals are diving into when they're getting into a project, a do-it-yourselfer. Those that might be paying along attention to these channels. They're not the best. I worked with the best, learned from them, and I took that information and put it into a daily project. Is it going to perform at the best? Absolutely not. But everything that you can collect from extreme elite racing bodies and incorporate into your engine, you might not see additional horsepower, but you know you're going to get more durability out of it. Speaking of elite performance, again, a little bit more of a rant here, a little bit more of a congratulations to the Force family, setting a brand new world record for top fuel drag racing. I believe it's 346.7 miles an hour. Wow. In my lifetime, we've gone from world records set by Eddie Hill, the first one to achieve 300 horsepower, and now we have, again, the Force family setting another world record. But who won the NHRA championship this year? The Stewarts. Okay? No matter what you believe in Tony Stewart and his NASCAR success or different racing success, realize he's a newcomer to drag racing, and he would not be in the same position if he had to do it himself. He's riding on the coattails of his wife and their experience. That's a fact. He is not that good. If he had to start from scratch in the drag racing world, he would not be where he is today without somebody else's work that came prior. We would not have the technology within piston design if it wasn't for the individuals that came before us trying different things, like Smokey Unic and the narrow pistons. Fact. With that, have a good one.